Everyone, I'm happy to share with you our work on the impact of the race neutral equation. I'm Ahmed Al-Mahi and I work as a clinical data scientist at Arctic. We develop AI models for spirometry interpretation and also for other pulmonary function tests. We use several models, several features to train our models, including the z-scores that are generated using reference equations. We currently use the race-specific equations, which are 5 GLI equations that adjust spirometry values to age, height, gender, and also to race. Recently, GLI published a single race-neutral equation by averaging the previous equations. And our goal here is to evaluate the impact of this race-neutral equation on a large representative sample. We selected our sample from UK Biobank. We selected 20,000 healthy non-smoker individuals from 16 different ethnicities, as listed in the table below, which we will get to in the next slide. We did two steps. First, we applied the GLI equations for FEV1, FVC, and for the ratio. And second, we compare the distribution of the z-scores over the 16 different ethnicities. This slide first shows three ethnicities: British, Indian, and African. I will explain our approach first on the British. What we see here is a normal distribution that is centered around 0, and we can see a small minority of the individuals are below the lower limit of normal. However, if we look at the Indians and the Africans, we find something different. We find that the majority of the individuals are below average, and we also find that more than 25% of them are below the lower limit of normal. The slide shows the bigger picture over the 16 ethnicities. We show three figures, one for FEV1, FVC, and for the ratio. To understand this figure, we need first to know that the box and the brown line represents the distribution and average for the race-neutral equation, and the colored dots represent the race-specific equations. We can first see that the brown line, the race-neutral equation, is in the middle of the colored dots, which is the race-specific equations, which means that the new equation is averaging the previous equations, which is fine. The second and the most important thing to see in this graph is to look at ethnicities from 11 till 16, which include Caribbean, Indian, Pakistani, Bangladeshi, African, and other Asians. In populations, we can see that FEV1 and FVC are significantly lower compared to other populations. While at the same time, if we look at the ratio, we can find that these populations are not lower than other populations. So, to conclude our work, what we did is a comprehensive evaluation of the race-neutral equation over 16 different ethnicities. And what we found is that specific populations have FEV1 and FVC reduced while compared to other populations, while the ratio in these populations are not reduced compared to other populations. So the first question that will arise here is if socioeconomic status alone would be responsible for this reduction in FEV1, FVC, we would also expect that lower socioeconomic status will lead to more exposure to risk factors such as smoke and more obstructive disease, so we would expect much more reduced FEV1 over FVC, but we don't see this here. Another thing is also, this might also have an impact on COPD. For COPD diagnosis, probably we don't see an impact because the ratio is somewhat stable, but the staging, which is dependent on FEV1, might have an impact, might be affected in these populations. We probably still need more research to identify if two individuals have the same z-score and come from different ethnicities. Would they have the same disease risk? And if not, then we still need a race-neutral risk prediction. One approach to do this is through AI, similar to what we do at Arctic, where we want to predict the disease risk. We train an AI model using a multivariate approach, so instead of using single features, we combine them. We use features such as FEV1, FVC, peak respiratory flow, and so on, and we train on diseased individuals instead of training on healthy non-smokers. So the outcome of this model is not these scores, but rather directly disease probabilities. I will present a poster about this tomorrow. I will be very happy to meet you there and also to welcome you at our booth. Thank you.